I think it's important to understand that the general consensus among the scientific and medical community is that Lyme disease is in fact a global pandemic. What do we have now? 80 plus countries worldwide involved. You look at the CDC reported numbers for Lyme disease, they're said to represent about 10% of the actual cases that occur each year. So the need for effective treatment has never been greater. And so I think I want to begin by quoting a couple statements issued by the CDC. The first, patients treated with appropriate antibiotics in the early stages of Lyme disease usually recover rapidly and completely. Second statement. This is just issued shortly thereafter, states, regardless of the cause of chronic Lyme, studies have not shown that patients who received prolonged courses of antibiotics do better in the long run than patients treated with placebo. Furthermore, long-term antibiotic treatment for Lyme disease has been associated with serious complications, end quote. So in other words, if you get treatment within the first 30 days, no problem, you're in good shape. But you do it after that, and you're doing about as good as the placebo group that were cited in that study. There's a couple problems with this. Number one, early stage treatment isn't achievable for the vast majority of people. If you follow my logic on this, stage 1, early localized Lyme disease develops 1 to 4 weeks after the infection. And 64% of the people never even remember being bitten by the tick, and 50% don't develop the rash, then early stage detection just probably isn't going to happen. And on top of that, most people remain asymptomatic for the first 4 weeks. And the CDC has already made it clear that they discourage the use of antibiotics with what they refer to as non-specific clinical presentations. And if they're basing transmission on being bitten by a tick, what about the recent studies presented by the American Federation for Medical Research, for example, that suggest that Lyme is a sexually transmitted disease? There's also mounting evidence to support the idea, the claim that it can be transmitted via urine, tears, breast milk, and contaminated blood. And there's further evidence suggesting that the condition is not merely a tick-borne infection in the first place, but can be spread via mites, spiders, mosquitoes, and fleas. So, in other words, unless you got bit by a tick, was sick within the first couple of weeks, developed the rash within the first 4 weeks, and actually started treatment, you'll most likely bypass your so-called early stage treatment opportunity, and according to the CDC, have as much chance for improvement beyond stage 1 as the placebo group that was cited in that study. So one observation to support chronic phase ineffectiveness, we're talking about treatment after the early stages passed, is that the vast majority of studies on antibiotics and Borrelia don't account for Borrelia reactivation. And I commend the CDC for recognizing the studies that clearly indicate that most cultures will reactivate after the cultures are treated with antibiotics. After they're separated, washed, and filtered, and placed back into the media, you're going to see the motility and reproduction return, which to me suggests that some, if not most, of the antibiotics used to treat Lyme may temporarily impact something like protein synthesis and produce a sort of metabolic gnat, but they just don't provide much in terms of kill rates. So if you have what they refer to as post-treatment Lyme disease syndrome, this is the name that they've given or most people just refer to it as chronic Lyme, the studies are saying that the potential for long-term lasting remediation just isn't there, despite the fact that, yes, temporary periods of improvement are seen after antibiotic treatment. I don't think anyone's going to deny that. But there's a heck of a price that you're paying, considering the danger from long-term antibiotic use in general. With that being said, I would like to propose a new theory on disease causation. And by the way, this theory relates to almost every chronic degenerative type pathology out there. But with Lyme, we have some supplementary modifications to the general theory that must be considered due to the fact that we're dealing with such a multifaceted microbial landscape. Lyme may be the most complicated condition I've ever seen. Yes, the theory of causation that I'm proposing recognizes Lyme first and foremost as a mitochondrial dysfunction in energy metabolism, but it's not quite that simple with Lyme. Because number one, any viable theory of causation on Lyme must recognize it as a multi-causation disease, given the numerous microbial factors that impact function at the level of causation. Number two, any meaningful theory of causation must separate the mechanisms of impairment from other factors that may be viewed as either a correlative variable or as a predisposing factor. And I think in order to bring clarity to the model, it's very, very important to examine these components before we get into the primary area of causation relative to mitochondrial dysfunction, so that we can begin to build a framework for actually understanding Lyme not only as a multi-system disease, but as a multifaceted disease that potentially affects every cell, every tissue, every organ, every system or process within the human body. So again, the three factors that must be considered if we're attempting to make sense of the somewhat chaotic complexities of a condition like Lyme disease are: number one, predisposing factors; number two, correlative variables; and number three, mechanisms of impairment. Beginning with predisposing factors. These factors pertain to conditions that may prepare a system for integration or enhancement or facilitate an actual mechanism of impairment. They contribute to causation, and they're very important, by weakening the body's ability to defend itself, for example, against toxins and microbes. There are other reasons, but these factors can often explain why some individuals could be asymptomatic while yet testing positive for Lyme. And I think it's also important to recognize that predisposing factors are often packaged as mechanisms for impairment, when in fact they are not. One of the most common phrases that we hear in medicine today is this so-called unknown etiology. And because there is somewhat of a lack of certainty about what actually establishes a disease state, I would say that the vast majority of medical terms are related to either symptomology or predisposing factors, or what the literature often refers to as a disease determinant, because these factors are, or you could even refer to them as a precursor to disease. They fit in better with pharmacology, which is naturally going to capitalize on the low-hanging fruit that these factors represent, which happen to be the very factors that are readily identifiable, and that when addressed can contribute to an improvement in the condition, despite the fact that the cause has never been addressed. It's kind of like your vehicle breaking down and the mechanic says, "Aha, I see the problem, the fuel's bad." That's the cause of your vehicle failure. So you change the fuel out, you swap it out, the vehicle seems to run a little better, but you notice that there's a slight knock in the engine, and so you take your BMW to the old wise German down the street who says, yes, your fuel was a predisposing factor, but the actual mechanism of impairment is a lack of compression due to the fact that the carbon deposits brought about by the bad fuel caused the piston rings to wear out, and now your fuel's just not getting compressed properly. And he puts in new seals and you're back to normal. Now, there was no problem with changing out the fuel, probably a good idea, but until the impairment is identified and addressed, the potential for a complete fix just wasn't there. Examples of predisposing factors could include genetics, epigenetics, immunodeficiency, environmental, nutritional, hyperacidity, hypoxia, microbial precursors like yeast infections, mold, and heavy metals, just to name a few. We don't need to delve into all of these, but a basic example would be someone claiming that hyperacidity, for instance, causes chronic disease, as opposed to viewing hyperacidity as a means to an end, or a predisposing factor that facilitates, for instance, bacterial overgrowth that can impair nutrient digestion, that can then lead to X, Y, Z, and so forth, all the way down to the actual impairment. So that brings us to correlative variables, also known as variables having a causal association or causal relationship. An example here is something like the relationship between diet and heart disease, for example. Both the Mayo Clinic, the NIH, state that cardiovascular disease is caused by atherosclerosis, or damage to the vessel wall, brought about by a bad diet and a lack of exercise, when there's not a shred of evidence, a shred of data that would actually support direct causation. Correlation, yes, absolutely, but causation, no way. It's just like the studies that say electromagnetic fields cause cancer. There may be elevated risk of leukemia, maybe a contributing factor. If you live by a power line or a high current transformer, yes, but again, that's correlative, not causative. Very important to differentiate between the two. Some correlative variables in Lyme, which most often could be viewed as just gross symptomology, include inflammatory conditions, apoptosis, cell-mediated neurotoxicity, and oxidative stress, just to name a few. So here's the million-dollar question. How does one resolve a correlative variable or a correlative symptom without understanding the cause and effect relationship between impairment and symptom? And we're going to return to that question momentarily, but I'd just like to say that I think the vast majority of practitioners employ strategies or treatments that target correlative variables, and typically that's done in the absence of understanding causation. So moving on to the third pillar of the theory, I would state that a unified theory of disease causation must consider the following: the mechanism of impairment at the level of causation. Symptomology, there's a place for symptoms. Symptomology is a measure of improvement or as a measure of progression. A unified theory in practicality must include a diagnostic and treatment model, which we'll visit in a later webcast. And finally, the true nature of reactive oxygen species that we often refer to as oxidative stress. We further propose that the primary impairment in Lyme is a mitochondrial dysfunction in energy metabolism caused by mycoplasma or other filterable forms, specifically cell wall deficient variants. These could be pleomorphic variants of Borrelia, Bartonella, and that the primary role of the Borrelia and the Bartonella are as predisposing factors in mitochondrial dysfunction, not as causative agents themselves, but as predisposing factors, primarily because of their ability to trigger severe hemolytic anemia and microvascular thrombosis, both of which are going to do what? Impair the supply of oxygen to the tissues, right? And an insufficient supply of molecular oxygen is most arguably the primary predisposing factor in mitochondrial dysfunction in general. Keep in mind the role of O2, both in the production of energy, the production of ATP, and the production of oxygen radicals like hydrogen peroxide designed to protect the cell from microbial integration. So again, we begin with the primary predisposing factor in Lyme disease is Borrelia and Bartonella, due primarily to their role in exposing the cell to hypoxic conditions. Next, the primary mechanism of impairment is the direct result of pleomorphic variants. These are bacterial species that lack a cell wall, could be described as a nanobacterial species relative to size. And why is that important? Because understanding the properties of these types of bacterial species enables us to understand how they can form bonds with transport intermediates like NADH, for instance. These transport agents, or electron carriers as we call them, are responsible for carrying electrons through the mitochondrial membrane. And when these transport agents like NADH are bound up or locked up by the unsaturated protein fragments from these pleomorphic forms, then energy production basically comes to a screeching halt. You'll see the emergence of cytochrome C oxidase deficiencies, along with a host of what we'd call respiratory chain defects. And that's going to be seen all the way through the membrane if the electrons from fuel metabolism aren't making it past first base, in this case the complex 1 protein. So piecing it together as a theoretical review, we have the predisposing factor of hypoxia brought about by Borrelia and Bartonella, leading to the mechanism of impairment or the microbial integration of the mycoplasma or the pleomorphic forms, and a resulting blockage of energy production. But in order to have a unified theory, it's very important for us to consider the primary correlative variable. And that we refer to as reactive oxygen species. These are little molecules that can be understood as reactive forms of oxygen. And they have a very functional role, several roles in cellular metabolism. They're involved in signaling, in regulating a multitude of intercellular conditions. These reactive oxygen species play a prominent role in cellular metabolism, along with their buffering counterpart, the antioxidant, and we'll discuss both of those, the reactive oxygen species, the reactive oxygen metabolites, along with the antioxidants. We'll pick up there as we discuss the role of energy metabolism in Lyme disease as the topic of our next webcast. So thank you very much for listening.